So in today's video, we'll be discussing about the rotational spectroscopy. There are of two types, rigid rotor model of diatomic model as well as non-rigid rotor. But in this video, we'll be discussing only about the rigid rotor model. Fine. So consider a diatomic molecule. It's kept at a distance r. So there are two masses, m1, m2, and this is, I'll just, okay, so this is omega. So the total length r is equal to r1 plus r2. From this we can find the center of mass of the system, which is nothing but m1 r1 is equal to m2 r2, where r1 is equal to m2 r2 divided by m1. Now I'll write this as equation 1 and this as equation 2, and therefore if I substitute the value of r2 here, I can write it as I'll substitute the value of this thing, substitute this to this equation. I'll get r is equal to m2 r2 divided by m1 plus r2. I can take r2 common. I'll get it as m1 plus m2 divided by m1. Okay, writing in terms of r2. So I'll write this here and keep it here. So r2 is equal to m1 r divided by m1 plus m2, and therefore r1 will be equal to m2 r divided by m1 plus m2. I can write this as third equation and this one as fourth equation. Fine. Now our goal is to find the moment of inertia. So the moment of inertia of a whole system is equal to what? Sum of it. Yeah. So I is equal to I1 plus I2. Moment of inertia is nothing but m1 r1 square plus m2 r2 square. Just substitute the values. You will get m1 m2 r divided by m1 plus m2 square plus m2 the square. Okay, m1 m2 square r square divided by plus m2 m1 square r square divided by m1 plus m2 the whole square. So I can take m1 m2 common, m1 m2 r square common. If I take, I'll get m1 plus m2 divided by m1 plus m2 the whole square. So gets cancelled. Finally what I will get is that m1 m2 divided by m1 plus m2 into r square. This one is nothing but what? Reduced mass. So I'll write it as nu r square. That's I is equal to reduced mass into r square. Okay. Now what you're going to find is the rotational kinetic energy of the system. So that is given by E equal to half I omega square, and this is nothing but we know L is equal to I omega, right? Here I can write E in terms of L. That will be E is equal to L square by 2I. Okay, whole square divided by I. So you will get I square omega square by I, which is equal to I omega square. So I can write it as L square by 2I. Fine. Yes. So quantum mechanically, the angular momentum L of a system about an axis of rotation is given by L is equal to h cross j into j plus 1, where j is a rotational quantum number which can take the value 0, 1, 2, like that. Okay, so if I substitute the L value here, so this one I'll be substituting here, I will get it as is equal to h cross square j into j plus 1 divided by 2y. Okay, here I can be written as this one, nu r square. So this becomes h cross square j into j plus 1 divided by 2 nu r square. Okay, this is the final equation. I can write it as equation, I think 6. So equation 6. Fine. So if I substitute, okay, if I put the value of j to be 0, I'll get the whole energy E to be 0. But if j is equal to 1, I'll get it as 2h cross square by 2 nu r square. And if j is equal to 2, it will be 6h cross square divided by 2 nu r square, like that. So we can draw the energy levels for this. So if j is equal to 0, I'll write one second, I'll write this like this. If j is equal to 0, E naught is equal to 0. Okay, j is equal to 1, E1 is equal to 2h cross square by 2 nu r square. Okay, so this is how the energy level looks like. So this is called 2b. We take this term as b, and so we can write it as 2b. This is 6b. This is 12b. Okay, yeah. So we know that E is equal to h nu, which is equal to hc by lambda. We can write like this, right? Therefore, this will be E by hc, which is equal to, we found the value of E, that is h cross square h cross square j into j plus 1 divided by 2 nu r square. I can write it as this as h cross square is nothing but h square by 4 pi square. So this is 4 pi square is here into hc, this hc. Okay, so mu r square, I'll keep it as I itself, 1 h close, we'll get it as h j into j plus 1 divided by 8 pi square. This thing is I c, where, okay, this is new, and b is equal to h by 8 pi square IC. Okay, so we can write it as into j plus 1. Okay, these are the formulas which you should keep in your mind. Okay, so that's it for this video. See you in the next one.